All right, make sure, loves, please, that your name is at the top with a dash R after, so we know what section you're in. And let's have you please hand those up and over now. Sorry. Doesn't matter. Yeah, big capital R. Excuse me. It's really good. Thank you. Yeah. Now, if you haven't already, go through, please, and log into your calculators. Who remembers what you need to press to start the log? Let's start off with that. Go ahead. Press 5. Your login is going to be the first letter of your first name, followed by your last name. And then your password is going to be what? 1, 2, 3, 4. So, some of you, do any of you have the login button grayed out on your computer? Sometimes that happens, but it tends to be later in the day. Thank you. So, if your name's Bob Smith, you put in B Smith as your username. Password's 1, 2, 3, 4. Let's see how much do we have. And have your note packets out, please. And your factoring checklist that we had from the other day. Looks like we're good. Logged in. So, how far did we get the other day? Because I need to make sure that I have the right file saved. I believe it comes in the other day. Did we get these ones done so far? Yes? And did we get these ones done or no? All right. So, go through right now, please. This was a little bit of a refresher. Try 2D right now on your own. Please go through and do 2D on your own right now. To identify your GCF, etc., factor out what you can. Do that now, please, for 2D. Another minute. Hands up, please, if you can tell me what your GCF in 2D is going to be. We got 2 people who can tell me. Your GCF in 2D would be. Go ahead, please. Good. Hang on. Minus how much? 3. Good. Keep going. That's a lot to go through and take into account. That's good. We did well. Questions on that one? Now, the first thing, if you look on that check down list you had from the other day, the first thing you always look for is a GCF, the very first. And then we sort of work our way down from there. A GCF doesn't necessarily need to be something that's very easy for you to see. Looking at this, and there's terms and stuff that we're going to go over, but as it stands right now, this expression given to you out in 3A is one big binomial. Binomials are 2 terms separated by adding or subtracting. So as it stands now, the expression as a whole, when it's listed out like this, is a big binomial. And what makes up the big binomial? 4 smaller binomials. Looking at what's there, the first thing that we need to ask ourselves when you're looking to factor down something like this, or at least to be aware of, is as of right now, look at the big binomial. There is a common factor, something you can undistribute from the left side and the right side. Take a look at what's there. And these are way different than the ones that you've seen before. It's supposed to. You can tell me what they think our GCF would be, or something you can undistribute out from the left side and the right side of this big binomial in A. What do you think? We got one person, two, let's even get five. Take a look at what's there. What could be something you could undistribute or divide out from those two? We got three people so far. Now, we can't take out just the x, because when it's a binomial like that, they're linked up and they can't be separated. But there is something coming. You're not there. Look at the binomial x minus 5. Can I undistribute an x minus 5 from the left and the right? You bet. Hands up, please, when you can tell me what you would be left with when you undistribute out an x minus 5. We got one person who can tell me. Two. Take a look at what's there. What are you left with if you divide out or undistribute out an x minus 5? Two. Three of us. When I divide it out from this side, I'm left with an x plus 6. When I divide it out from that side, I'm left with a 2x minus 5. So list that out. We're undistributing it out. And by the way, if I redistributed this out, what would I have? The original. Do we have questions on what's there now? Is there more math that I can do? What's in front of you? Take a look at what's there. Is there more math that you can do? Who sees what more we can do? You tell me. From as it stands right now, we have done our first factoring, and you're looking at this. And if you left this on your paper, if I left it up here, I hope you all would be outraged and offended. What more can we do with what's there? And do what to them? We can't keep simplifying. There's more that we can do. Go ahead.
You can take that up from x and 5 from n to 1.
No, we can't divide the whole thing by 2. We can't take stuff out. Look at what's there. Don't overthink it, because it's kind of telling you what to do in a little bit of a subtle way. You want to say that? No? What were you going to say? Is it x or base? No. What were you going to say? Yeah. Look at what you're left with over here. Brackets are just second parentheses. Technically, by the way, what number right now is in front of these parentheses? A 1. So I've got x plus 6 here, distribute out of 1, plus 2x plus 5. So really, at this point, do I need parentheses on it? No. What does this become? 3x plus 11. Thank you. So go in right now. Combine your like terms when you can. Sometimes you need the parentheses. Did I need to list out the parentheses when I was doing this example? And the answer is technically no. You didn't need it on that question. Would you be expected to do something like that? And the answer is sure. We have one like that waiting for you on your assessment when we come in tomorrow. Questions on that one? We're going to try the same thing now in question B. Look at question B. First thing we look for when you're tasked with factoring is to go through and factor that down. Is there a GCF? Yes or no? And hands up, please, if you can tell me if your answer is yes. What's it going to be? We got 3 so far, 4. Go back to what I said. That quantity, yeah. So we can factor out an n plus n quantity squared. And by the way, that's another thing on a side. When you all come up, you have very bad, well, the people you've had before have modeled profoundly bad language for you. If you need to tell, if you're telling me an answer out and you need parentheses there, you say the quantity up, okay? So, and the difference is this, because when you go on beyond high school, not everybody's as nice as we are here. If you had said n plus n squared, that's this. Is this the same as that? No, you want parentheses there, you say the quantity of. That's it. It's a little one. We try to correct it as we go on. Another one it starts to hurt your brain a little bit. There's people in the building, and actually the majority of people in this department. What is the upper half of a fraction called? It's called a numerator, okay? And the bottom half is called a? Yeah, it's very frustrating because we have people say tops and bottoms of fractions. There's no such thing. When we talk about square roots or radicals, there's the number underneath the radicals called the radicand. It's not like some magic number that has no name. You'll make sure that you know all of them anyways. It's actually very fun to read. But make sure that you say it right, because I'll stop you sometimes. Maybe you need parentheses there and you didn't say it. So we'll make sure that you're saying it right before you go. What's left after I divide out my GCF? Hands up, please, if you can tell me. In this question, what I'm left with after I take out my GCF? Go ahead. Do we have questions on that? Don't tinker around with the squares. They're not like bases. Leave it as is. Questions on that? Now, this next question, we're going to skip C and bounce over to D. So when we're doing this out, please understand we're talking about doing question D out. When you do this question out, this one's going to be a little bit awkward. There's a bunch of steps to it. And people tend to, especially those who don't get through Algebra 2, they give up really, really, really easily and or say, I can't do it. Stop. Never tell me you can't do anything. Take a look at what's up there in D. First thing we need to look for to factor it down is a GCF. Is there a GCF? If so, be able to tell me what it is. Hands up, please, and we get 8 people that can answer that question. Is there a GCF? And if so, what would it be? Go ahead. And he said it correctly. We've got to take out the quantity P minus 5. Now, in brackets, I use brackets. You can use a second set of parentheses. It's just to make sure that it looks nice. What am I left with? Hands up, please, if you can tell me what I'm left with when I undistribute that out. I've got 1, 2, 3, 4, 5, 6 of us. Go ahead. What's between those two? Now, when she said that out, you almost, and I'm not going to correct, well, kind of correct, she didn't necessarily need to say one of those two sets of parentheses. Which parenthesis did she not necessarily need to say? Which one wasn't mandatory to say? Because one of them is mandatory to say. Which one out of the two was not mandatory and why? Out of the two is not mandatory. First one. Why was it necessary for her to make sure that she said the quantity 3p plus 4? Why did we need to say, why did that one need parentheses for sure? We got one person who can tell me? Think what would happen if she hadn't said it. Go ahead. Because of the negative sign there, yeah. So you did a great job of making sure you said the right stuff. Now, this is the part for me where it gets frustrating, because as of right now, this is a 7th grade math question. And we got people who go, this is too complicated, and I quit. This is hard. Look at what's there. What is the math telling you to do? Not me. What is the math telling you to do? What more can you do as of right now? It's not some gargantuan undertaking. But just look at what's there. What can we do? Now, which one are you talking about? These two? These two? What do I need to do in order to get rid of them? See how there's that -1 in front? We do need to drop them. And actually, can we drop these first two? Can they go away? Yeah. Can the second two go away? Kind of. What needs to happen in order to make them go away? Distribute the negative. So as of right now, and don't be some mental math all-star, we're to this point. Now, what's the math telling you to do from here? Hands up, please, when you can tell me. I'm hoping that this isn't that tough, or that much of a stretch. There's a lot there, but I'm hoping to say, oh, this is, it's 7 stuff. Okay? Subtract what? Be more specific. Okay, so what do you get when you put those two terms together? And then what do you get when you put your numbers together? -2. So as of right now, we are to here. All you did was put like terms together. As of now, if I walked away, I'm hoping you would be irritated and you can see my mistake if I walk away right now. Hands up, please, if you can tell me what more we can do at this point. Let's see if we can get 5. We got 1, 2, 3, 4. Now, if you FOIL that out, you're going to get another form of the original, but it's not going to be factored down. You would get a bigger form of what's on the left. Who can tell me what we can do to break it down even further? No? Close. Ish. We're getting closer to what sounds right. What else can we do that's up there? Divide by one. Not the whole thing. There's a GCF in the second factor of what? I wouldn't take out a 2. You're close. What do you think I want to take out from that second factor? Not -1. Put it together. Nope. Nope. -2. What can I divide out from both of these? A -2. So if I take out a -2 now, what would I have left from both of those? Because they're both divisible by -2. That was right. Take that GCF out. What would you be left with if you divided that out? You see? P plus 1, yeah. And this is the last bit of this, and it gets awkward, especially to this point, because we're sitting there going, you did all of this. I still think this answer looks kind of weird, and we wouldn't ever leave this sort of as our final answer. Does anybody see why, even visually, this doesn't look like how you would normally list something out? There's double parentheses there. I heard somebody mention that. What's up? You tell me what you see about the Neos. How does that make sense? Sure, you could, but that gets you back to the step up. Think of this like a ladder. You're trying to get to the bottom of the ladder from the top. The top is the big expression, the bottom is like the factors. You're going down the ladder still. If you had multiplied them together, you'd be sort of going back up the ladder, giving alternate but equivalent expressions. Why does this look awkward? There's 2 factors right there. You have a -2 in front. Do you ever really leave a multiplier like in the middle like that? Let's hope not. It should go smaller terms to bigger, so as you list out your answer, like single terms go in the beginning, then binomials, trinomials, and so on. So this would be as far as I would expect to take it. Is it a hard example? Absolutely. Because I want you, and that's the other thing that we have to make sure we're crystal clear on, I need you to understand unequivocally, everyone in here at some point is going to be getting questions wrong. You will probably get at least one question wrong you're answering every day. If you're not getting a question wrong, I'm asking ridiculously easy questions. And one of the things that gets frustrating is, especially in Algebra 1 and Geometry, they take all of this time to treat you like you're a little baby veal, a little baby lamb. And they sit there and go, oh my God, we can't give them the hard questions because then they're going to have to think. And then they get nervous and then they panic. And then they might get the question wrong. And if they get a question wrong, their self-worth is going to fall just right into the toilet. They're going to think that they're horrible people. And so let's give them a question like, let's add 4 plus 2 together. And you're 15 years old. Get real. I want you, and this is not true, I'll be honest. I want you to fail when you're doing it. I want you to know that you're going to take attempts that won't work. And do you sit there on the ground and cry? You get knocked down, what happens? You get back up. The one thing that I found the most interesting was I had a kid about 4 years ago. His name was Chris, the last kid in this row. And I remember sitting there, and Chris would look at me in class, and he stuck it out all year. He needed 3 math. You need 3 math credits to graduate. He was a senior. He had failed 11th grade intermediate algebra and decided I'm going to take algebra 2 instead. And he sat there in the back seat of this row, and he was bewildered all year. Might as well have been speaking another language. And he was getting 40s all year. And I said, you know, why are you even here? Like, what do you want to get? I need this to pass, so on. And I think I can do it. I think I can. All right, show me. You know what was funny? Chris got knocked out every day in class. Every single day. He had an average in the 50s. Not only did he show up every day and he participated, probably more so than anybody else. But then the exam came along. And at the end of the year, and I told Chris, I go, whatever you get on the exam, I'm going to give it to you as your quarter grade, if that's enough to make your pass. Because you sat here and tried so hard all year. God love you. I can't imagine failing a kid like you. He sat there and he got an 87 on the Regents exam. Pulling 40s every quarter. Why? He goes, it finally came together at the end. And I said, what do you mean? And he goes, and apparently this is some course, I can't attribute it directly to him. But he goes, I got knocked down 99 times, but the best feeling was standing up the 100th time at that exam. He goes, I finally got it. And the irony, that kid that failed would have failed the course. And by the way, even he did so well that it made up for the bad quarters that he had before. Like, he had that many points left over. He actually passed without help from me. He did better than 2/3 of the kids in enriched that year when he got an 87. You have to get over this fear of failure and struggle. I want you to struggle with this. Like, struggle. Own it. Take it times, it's not going to work. Oh, well. Okay? So, that's one of the things, too. Just make sure you don't give up. Everyone in the beginning thinks, especially back in Geo, I watched the kids that walk around here. You don't even know when you're in the rooms. We could walk by half of the rooms that teach geometry and algebra 1, and you see kids in the corner like this. Are you ever going to be like that in here? That's it. Raise your hand if you've heard things about me before this year. Some of you own it. I don't show it. They probably were something like, he's loud. But raise your hand if you heard I'm loud. And or heard me do that. You've heard that I'm loud. Oh, I think I had your brother there, right? Yeah, you sat right there. He's probably hard of hearing. And by the way, the people are getting there, you can bring it in. I go, we're going to get your card set up in a minute. I call on every one of you. There are no mental breaks. None. You got to be on all the time. And guess what happens? Shockingly, we do outstanding on our exams. Who would have thought? If you make you work the whole period, you do well on a test. Shocking. And the other piece, though, for you all is why do you all want to do? Well, let's say this. And we're going to have an assignment soon too where you do this and write out why you actually want to be here. Like, what does it mean to you? Because the kids who want it are the kids who do the best. I will give you everything it takes to get a 100 on that exam if you want it. But I'm not going to sit there and check if the other one did. Why are you here? My parents told me I had to. It would be like, I used to, well, I'll say this. When I work out over at Midtown Downtown, and it's sort of expensive to go there, and they have trainers there that are like $100 an hour. Like a physical trip, someone who tells you, pick that up and do this with your arm, and they get paid $100 an hour. And there's people that are there that are paying the trainer, and they don't even want to be there. And you sit there and watch them, and talk to other people they walk on. Why are you wasting your time? Life is very short. If you don't want to be there, I don't want to force it. I know you. But I want you to be really, really successful. We're even going to see, after you leave today, you should be able to answer 2 of the questions on the Regents exam over here. 2 of them. Now, take a look at example 4. There's 2 ways you can do example 4. You've got to factor it down. Is there a GCF in 4? The answer should be a yes. You actually have 2 different choices for a GCF in 4. Hands up, please, if you can tell me one of the 2 choices you have for a GCF. Go ahead. Take a look at this guy here. Maybe I was talking about this one. This one right here. There's 2 different GCFs you could pick. Who can tell me just one out of those 2? Just one. Go ahead. You could take out an A. If you take out an A, please, what would you be left with? Square. Good. You're absolutely right. And that's not the only possible answer you could give. I'll wait for 6 of us who can give another alternate but equivalent GCF that could have been chosen in the beginning. We got 1, 2, 3, 4. There. What else could you have done? We got 3, 4. Try. What do you want to say? You could also take out a negative A. If you do that, what are you left with? Good. Keep going. Why is that one going to be harder to do? Because of the negative in there. You got to remember to change the signs. Why is that the one I probably want you to use? Take a look at the trinomial now that's left over. Looking at that trinomial, it's easier to factor that one down or to see if it does factor. Are there, and take a look at what's here. Is there still a GCF here, yes or no?
Yes.
There is. What is it? The trinomial here, is there still a GCF?
No.
No. Is that a difference of perfect squares? Look your way down that check down list. Is there a difference of perfect squares there? No. Difference of perfect squares when there's 2 terms, perfect squares subtracted. This looks like a fast factoring, which is number 3. Are there numbers that multiply to give you 5 and add to give you -3? No. So guess what? You're done. You walk away. But understand also, and that's another thing that they don't do a good job of showing you, you actually, not everything that we give you factors down. When things don't factor, they're called prime. Take a look. Here are the ones that we need you to make sure you're solid on. Bounce over to page 2 at the top. You've got example 5 to start. We need to go through and check what this is going to do. And this is why, particularly for those of you who struggle, you have that check down list that I gave you. Work your way down that. The first thing you need to look for is a greatest common factor. Is there something I can divide out from those 4 terms? Is there something that they all share in common that I can divide out from those 4 terms? Yes or no? For example 5 at the top, you could take out some form of a 1, maybe a -1. But other than that, there's nothing in common for all 4. Not for all 4. The second thing that we've got to look for is the second one, difference of perfect squares. Look on your list, it's not on that. No. Look at the same example 5. There's no GCF. Is there a difference of perfect squares? Where's your check down list, guys? Have that out from the other day. Is there a difference of squares there? Take a look at that. Does this match a difference of perfect squares? No. Difference of perfect squares are binomial questions. Is this a binomial? No. 4 terms, actually more than 3 terms is a polynomial. Next thing, take a look at that, and the next one is this a fast factoring? No. Look at fast factoring. How many terms are there in a fast factoring question? It's not on my face, it's on your paper. That factoring check down list. How many terms are there in a trinomial? There's 3 terms. How many terms are here? 4. Guess and check, we haven't done yet. The next one after that is grouping. In general, how many terms are there in a grouping question? Take a look. How many terms are there if we're trying to factor down something by grouping? 4. How many terms does this have? 4. What does it tell you to do for grouping? It tells you to take the GCF of the first 2, and then the last 2, and then look at the expression as a whole and see if we can work forward. So, first thing up, look at the first 2 terms, and now the second 2 terms. When I look at the first 2 terms, is there a GCF there? Hands up, please, if you can identify it. We got 1, 2, 3. We're doing great in the back. What do you want to say? A, and what's left when you factor that out? Yep, A times the quantity X minus Y. Now, look at the next two terms. Hands up, please, if you can identify what the GCF for those is going to be. Go ahead. What kind of B? Positive or negative? I'd say take the positive B out. And what's left when you undistribute a positive B from both of them? You're still not done. Why? And at this point, I would expect you to know what to do at this point. Why am I not walking away right now? Hands up, please, when you can tell me. I've got 1, 2 so far. Thank you. 3. I can't walk away yet, and I'm not done yet. What do you want to say? No? Careful. Look at what's there. Is there a GCF as it stands? What is the GCF between those two halves? So when I take out or undistribute that X minus Y, what are you now left with? What's that? A plus B, perfect. Questions on that? Now, that only works if you can, and how many times did we GCF there? 3. Once here, and then once for the whole thing. So 3 GCFs. It only works, by the way, if these two match up.
I don't really want to ask this, but what's the term? These are the terms of figures like the
So,
parentheses,
this would be like a binomial. This is a single here. I guess, can you tell me, how did I say it that, where you were
Well,
at?
when you said,
So if
I saw it as a polynomial when you started mentioning these terms. And it was really
So how many terms does a trinomial have?
3.
3. And their terms are some combination of a variable and a coefficient separated by addition or subtraction.
Okay.
So when I'm giving out a trinomial, it could be 3x plus y minus 4. That's a trinomial. 3 terms, term 1, 2, and 3. Okay? This right here, 3xy, is a monomial because there's no addition or subtraction between them. Okay? If I listed out 3 plus x plus y, that's a trinomial. So the terms are the components, I guess, separated by addition and subtraction. Okay? And again, and thank you for asking, because part of the problem that we have, you all have come here from very diverse feeder courses. I'm not trying to talk over your heads, but I also need you to not sound like kind of babies when you go off to college. And one of the reasons is you're capable of understanding like what big words are and using them correctly. So like when we're talking, for example, about terms, we need you to know what those are. But when we're saying things like, you don't want to say the top of a fraction, which person sounds smarter? The person says the top of the fraction or the numerator of the fraction? Which one? Numerator. It can be the exact same person. Fool people into thinking you're smarter than you are. That's the worst case scenario. Trick people into thinking you're smarter than you are. That's what we want. Okay? Now, I want you to try out example 6 on your own. You may make a casual mistake on 6, and that's all right. That's why we've got erasers. But give out example 6. Give it a try right now. Let's take a look at example 6. What type of factorization would I want to do in example 6? Hands up if you can answer that. We got 1, 2. What's the name of the process we're going to be working with? Go ahead. Grouping. If we do grouping, let's look at our first 2 terms and our next 2 terms. So I've got these here and these here. What can I factor out from the first two terms? Hands up, please, if you can tell me what we would have. Go ahead. 3, and then the quantity x minus y is correct. Hands up, please, when you can tell me what you want to have or what you want to do in the second half. There's 2 paths we can go down now. Go ahead. Now, who took out a positive a? Watch what happens when we do that. If you take out a positive a, I'm now left with what? Who can tell me, please? Hands up when you can tell me what you would be left with if you divided out a positive a. Go ahead. Negative x plus y. Do I have a match? Yes or no? No. So I go, but it's really close. What else could I have taken out? And we had somebody correctly identify I'm taking out a negative a. Who was it that told us that? Is that you? Keep going then. What's left when you take out a negative a? Why was it good for him to tell us, why did we stick or want the negative a there and not the positive a? What's the benefit? I got 1, 2. Think about the y. Go ahead. The same, what are those 2 terms called? What do we call 2 terms put together? Remember? They have a common binomial. So what is that common binomial that you're going to take out? And what are you left with? There you go. Was that tough for us? I hope not. Yes? Because when you divide both of these, remember you're really dividing both of these by a negative a. So if I have positive ay divided by negative a, the a's are going to reduce to 1 and you've got negative. Yeah. Remember, you're sort of undistributing it too, if that's an easier way to process it. Okay, if I pull that out or divide it out, what am I going to be left with? Do you have questions on that one? Okay, now, there are going to be times, take a look at example, well, we'll do example 8 together. Look at example 8. First thing we always look for is what? GCF. Is there a GCF for everything in there?
Yeah.
No, there's not. Not for everything. Now, is it a trinomial? No. So is it a difference of perfect squares? No, it's not going to be a fast factoring. It's going to be grouping, except I'm going to have a problem. This is the part 2 where you've got to be a little bit of a problem solver. So, I've got these 2 here and these 2 here, and if I do it by grouping, normally I say, all right, I'm going to take out a GCF from the first 2 and the second 2. There's a problem. Hands up, please, if you can tell me what problem I'm having. Just play it forward a step. What issue am I going to have if I'm doing grouping right now? What's my issue? Go ahead. And really not in the second 2. There's really no GCF for either of them, except something else. This is the part where you have to be a problem solver. You can still do this by grouping. Do you want to give it a try? So here's what you've got to recognize. Can these terms group? Yeah. As long as the signs stay the same. So instead of writing it out this way, is this way helping us? No. There's more than one way, by the way, that you could rewrite this to help yourself out. When I did this, I think I might have done it the same way that you did. I saw a 5 and a 10, and I see a GCF there kind of easily. What do the 5 and 10 share as a common factor? A 5. What do these guys here share as a common factor? A Q, yeah. So I rewrote it as this, which is what you're going to go through and do. I'm going to regroup it, make sure the signs stay the same. But I'm going to rewrite it as this. What's the benefit of rewriting it that way? Hands up, please, if you can tell me. What's good? How did that help us work towards an answer instead of putting the pencil down and saying, I can't do it, this is hard. There's my mom. We got 1. What's the benefit of doing it? What's the point of the rewrite that we just did? We got 3 people that can tell me why we just did it. Am I trying to burn through time? Get paid more? Who wants that? There's a GCF on the left and the right. What is the GCF from the first 2 now? Hands up when you can identify the GCF from the first 2 now. Got 4 people. Thoughts? What do you want to say, please? Great. And what's left when you take out that q squared, please? Perfect. Who can tell me what their GCF for the second 2 terms is going to be? What kind of 5? And what's left?
P squared minus 2.
Why do I got a really good feeling I just did the right thing? We have a common factor of p squared minus 2. Hands up when you can tell me now what your final answer is going to be. I got 1, 2, 3. Go ahead, please. Yep. P squared. Good. And? Squared. Yeah, that's fine. Questions on that? Now, here's what we're going to ask you to do for homework tonight. Did we have you work out of this grouping last time? Yes or no? What did you do? 1 through 13. So let's please tonight have you do this. Let's have you do, let's have you please do 17 through 24. Do all of them, please. Now, there's one thing that I'm going to need all of you to do right now. Maybe it's twofold. Let's see this. Have your phones out or your computers, whichever one gets the internet. No, not rank order, open-ended. So what we're going to have you do is this. Go, if your phone gets the internet or your tablet gets the internet, I don't care which one. What you all are going to do is, this pushes it out. So you're going to go to this site right here in whatever browser you got, polyv.com/jmac912. You got a question there waiting for you. Okay, and it is this question. Is it working? Yes or no? Has anybody gotten there? It's polyv.com/jmac912.
Yes.
Working? All right. So you all are going to be answering that. And what's going to happen is I'm going to call the first 2 rows up in a minute. I have all of your names down, except I need to know what you actually get called. So if your name is like, Roberta, and you go by, Edith or something like that, please let me know, like, what it actually is. And, let's see, what was, and I need to get, so here is, okay. So this is the list that I have. Oh, this isn't even one. So this is the name that the names that I have so far. If your name is right and that's what you get called, that's fine. If not, tell me what you get called. If there's spelling errors or your name's not on there, let me know as well. What we'll do is we'll call you up by rows. So can I get the first 2 rows? Come on up, please. That means you guys stand up and come over here. What's that? It's yes. Actually, well, it's just polev.com/jmac912. Okay? Anyone else need that? It's polev.com/jmac912. The rest of you come on up, please, so I can get your names and make sure that this is down right. Come on over. All right. What's your name, bud? Which one? You go by Quinn? Yep. Thank you. Next.
Dom. Just call me Dom.
Dom? Perfect. Thank you.
Anthony Keller.
And you go by Anthony or Anthony? Okay.
Andrew Giroux.
And
Andrew.
Andrew? Okay.
Harvey.
Tyler. And you go by Tyler? Okay.
Oh, wow.
And you go by Christina?
Yes.
Okay.
Gage.
Okay, you go by Gage?
Yeah.
Anything else? What do you want to be called?
I don't think there's anything for Gage.
Okay. Yeah, I don't think either. Sorry.
Sebastian.
Do you go by Sebastian?
Maybe.
Seabass? All right. Which one are you? B. And it's Bettina? Okay, thank you. Adriana. And you go by Adriana? Okay. Next two rows, come on up. Ayla. And we had yours. Are you on here? Yes. You were the one that was over the first day. You're good now, right? And you go by Ayla?
Yep.
Okay. And you go by Cameron? Okay. Dylan, and you go by Dylan? All right.
Julia.
And you go by Julia?
Yep.
All right.
Greg.
And you go by Greg?
Yeah.
Okay.
Oh, you want to have anything?
You're fine.
Oh, Michaela.
Michaela? And you go by Michaela? All right.
I go by Beth.
All right. Where are you? You're Michaela also? Which Michaela are you?
MC.
So with a K here, this one? What's your last
Yeah.
name?
Crazy K-R-C.
Okay. And what do you go by? Mac? M-A-K? Or M-A-C?
Sure. Since you're already
All right.
MC.
I'll let you. We'll let it slide.
Paige, and I go by Paige.
Paige? Okay, thank you. Laura Lynn? Okay.
John,
And you-
me and I go by just Sweeney, if that's okay.
Okay, so I'll put a star to make sure that we know that it's just you.
I'm Marissa, but you call me either Marissa or just Rebus.
Okay. So I'll probably go by Marissa if that's all right.
That's fine.
Okay. What's your name, bud? Jack? Okay, go by Jack. All right, thank you. Thanks, guys. You did a great job today. If you haven't come up yet, or if your name's not right, what's your name, honey?
Madison, but I go by Maddie.
M-A-D-D-Y?
DDY.
All right, and that's the right one with the P for the last name? Okay, thank you. Anybody else I didn't get to? All right, loves. Have a great rest of your day.